I think the key word in the mission of CodeArt is inspire, and so I hope that everyone walks away today feeling very, very inspired, and I certainly can attest to the dynamo that I am about to introduce as our opening keynote speaker as someone who's very inspiring. We have with us here today the Senior Data and Applied Science Manager at Microsoft, Dr. Ehi Nosakhare, and she is quite multi-hyphenate, I would say, and she is basically leading a team that is designing, developing, and implementing machine learning solutions, and is quite passionate about both the ethical implications of AI and machine learning, as well as solving real-world problems, which I think you'll see is kind of an undercurrent of a lot of the conversations that we're having here today. So I am encouraging everyone to please be curious, but hold your questions to the end. We'll be stewarding a Q&A at the end, but I am very, very pleased to welcome Dr. Ehi Nosakhare up to the stage for our opening keynote conversation.
Thank you so much, Ellie, for that generous introduction. Like Ellie said, my name is Ehi, and today I'll be talking to you all about artificial intelligence, the impact that it's having, some of the challenges that it has faced, as well as some opportunities that I see. But first, I would like to talk about how I started, or how I got to where I am. So for me, it started with a very simple electric circuit, like what you're seeing here on the slide. It looked very similar to this. It was my assignment in my 7th grade integrated science class when I was in elementary school, I believe. We had to connect wires, batteries, and switches on this wooden board. And when we started out the assignment, it seemed very abstract at first. But I honestly would never forget how I felt when I turned on that switch and the light bulb came on. It was literally an eureka moment for me. It was the first time that I really understood. I mean, we had electricity at home. I would turn on switches and the light came on, but I never really understood it. So the first time I really understood how electricity worked, and this sparked the curiosity I had in the sciences. In my high school, the guidance counselors used to talk to us. They used to tell us things like, if you are interested in physics, you need to be an engineer. If you're interested in biology, you needed to be a doctor. And if you liked chemistry, for example, you were somewhere in between. I think because they didn't really understand chemistry, but I digress. But they would typically say you could either be a doctor or a chemical engineer. And I really, really liked physics, especially since that circuit board assignment, and I knew I wanted to be an engineer. My dad was an engineer. My uncles were engineers. I was surrounded by them. But it was really hard for me to picture myself as an engineer because I really, up until that point, had not seen any woman be an engineer. And so I remember even one of my uncles telling me then that I needed to focus on becoming a doctor. Well, I'm now a doctor, but he meant like a medical doctor because as a woman, that was better suited for me. But I was really conflicted because I really liked physics and I enjoyed it better than biology. And so one day I came back home from school and there was this lifestyle magazine on the table. And I flipped all the way to the back, and it had this profile of a female petroleum engineer who worked in Shell at the time. And I still remember that picture to this day. This woman had on a white hard hat on her head, and she also had orange overalls. And she talked about what she was doing in Shell as a petroleum engineer. And that was the very first day that I realized that, wait a minute, I could actually be an engineer. And like you can see in this quote, this is a quote that I find really interesting, even though it's a hyperbole, but it does capture the essence of the fact that you really cannot be what you see. And so I am really glad to this day that I picked up that magazine because I feel like it has led me to where I am today. So what exactly has my journey been? Right after high school, I went on to study electrical engineering at Howard University. And there I focused on math, physics, signal processing, electrical engineering. It was really exciting for me. Afterwards, I felt like I really needed to learn a bit more about what I had been seeing in school. And so I applied to PhD programs across the country, and I got into MIT. And at MIT, I started doing signal processing like I was doing in undergrad. And a chance encounter with this professor who was working at the intersection of signal processing, machine learning, and healthcare really led me into the field of machine learning for healthcare. And that was what I did my dissertation on when I graduated. So now at Microsoft, I work primarily in artificial intelligence and machine learning, and I currently lead a team that uses ML, AI, DS, all the buzzwords, to accelerate product innovation, and we do this responsibly. And we do this across a range of applications, including our productivity suites like Office, Cloud, Azure, as well as our AI platforms. So now you've probably heard a lot about AI, ML, DS. Those are like the buzzwords that typically tend to go around, and probably wondering, what do they actually mean? I think about like trying to explain to my mom or my dad what AI or ML means, and oftentimes they have this picture of the sci-fi movies that we watch as AI being like this terrifying robot that is coming to take over the world and change the world as we see it. Well, AI will change the world as we see it, but not as a terrifying robot. And it's actually more like, think about a child, right? And you keep showing the child over and over again how to distinguish between triangles and squares, and you do that over and over and over again until the child is able to do it. That is sort of what AI is. And it helps computers to mimic human behavior, right? And you also see that machine learning is a subset of AI. And this allows machines to learn patterns from data, and it uses this learning to have computational tasks. And there's also deep learning, which is a subset of machine learning. And the thing was, as machine learning became more popular, the data that it was using became bigger and bigger, and we needed more complex algorithms to be able to analyze these huge data sets that we were now gathering. And that's pretty much what deep learning does. And so in a little bit more detail, machine learning's primary goal really is to learn patterns from data, right? And once you learn these patterns, you want to be able to predict an outcome and then continuously improve the algorithm. And so I'll give an example. You all are in Miami, the weather is great, super nice and warm, always sunny. But if you're from the Northeast like I'm from, in Boston, it's cold, sometimes it rains, the sun is hardly ever out. And so if I wanted to develop an algorithm or predict whether or not it's going to rain tomorrow, because I want to know whether or not I should have my umbrella with me, what I would do is I will gather data from the past, which is what we typically call the training data, right? And so once you gather data from the past, you will then identify certain attributes of that data. So things like, on a particular day, what was the temperature? What was the cloud cover? Did the sun come up or not? And that's what we would call features or attributes of the data. And you would give this algorithm all these features and all these attributes, as well as what we call labels. So on this particular day with, say, 56 Fahrenheit, this much cloud, this much sun, it rained. On a different day with different sets of attributes, it did not rain. And so you would give this algorithm tons and tons of samples of this kind of data, and it trains the algorithm. And so that's what we call training. And that's how the algorithm learns, or that's how ML learns. And then you would ask it to make a prediction, right? You would say, okay, given this set of what we feel tomorrow is going to look like, is it going to rain or not? And that's typically how machine learning works in a nutshell, but it's definitely a lot more complicated than that. I'm sure you've also heard about data science, which is a field, right? It's a multidisciplinary field that is really focused on discovering actionable insights from data, right? And it typically starts with a business problem or with something that you want to solve. And then you would go ahead and you'd acquire the data that is required to solve that problem, and you typically do some data pre-processing, like I talked earlier, which is like identifying the attributes or the features in that data that is relevant. And then you do some exploratory data analysis, as well as some modeling or experimentation. It's at the point of modeling and experimentation that things like AI and machine learning comes in, or deep learning, right? And then after that, you typically get like visualization or communicate your results to stakeholders. And so that's how the field of data science is. And how does it all come together? You would typically have AI, which is the subset of algorithms. Machine learning is a AI, like it's a field of algorithms. Machine learning is a subset as well as deep learning. And then data science, it's really encompasses some of AI, some of ML, some of DL, but then a host of other things. And that's sort of how all these three things come together. So I would like to talk a bit more about AI in common technologies, or in things that we see right now, starting with social media feed, right? So as you're scrolling down your favorite app, you name it, TikTok, Instagram, Facebook, Twitter, oftentimes you see selections of posts that you have liked or recommendations based on what you may have watched. That is really AI or ML in action, right? It's able to figure out what you've looked at, what you've clicked on, what your interests are, what are the interests of some of your friends or in these apps, and then show you what it thinks that you might be interested in. Another popular example of AI in common technologies, and I'm going to use AI MLDs interchangeably, and if I need to be specific, I will be specific, but if I use AI, just assume I'm talking about ML as well. You also have recommendation and search engines. So when you are trying to look for a movie, Netflix, for example, right, it would typically tell you, because you watched this, you should watch that. Or people who have watched this movie A have also watched movie B. That is AI or ML in action, right? It's able to learn from your habits and predict or show or recommend to you what it finds is interesting or what it thinks you could be interested in. Also, when you want to search for your favorite thing on Bing or on Google, right, being able to show up those results and rank which ones are most important to you or which one the thinks is most important to you, it's also AI or ML in action. And finally, digital assistants, right? Hey Alexa, hey Google, Cortana, hi Siri, all of this uses AI and ML, specifically language technologies. It's able to identify the words that you're speaking, translate that to some instruction for the machine, and then it fetches the results for you. So these are some of the examples of AI that we have in common technologies. Moving on to a bit more concrete, like how AI sort of impacts our society. And since we're here at Code Art, I thought I would start with like AI for art. So what you're seeing here is a picture that was actually generated by an algorithm. And as a tool, it's able to imitate and reproduce an artist's style. And in this particular situation, the artist fed the algorithm examples of his work, and the algorithm was able to generate even more art that was similar to what the artist did. And so AI-powered tools can actually make artists be more creative and be more productive. And the field is seeing more and more of this type of work being developed and grown and improved. And so there's definitely that intersection. If you're interested in art and coding and AI and ML, there's definitely room for you to be part of it. We also have AI for agriculture. This one I find really fascinating because you can typically use sensors. So again, AI is really powered by data, right? And so once you have sensors installed in the farms, you capture data that you can then use to monitor soil health. So these are things that can help the farmers monitor soil health, try to minimize the risk of crops failing. So for example, using the data that you have or the history that you have, you can sort of like study the trends, right? And provide recommendation to the farmers to say, hey, if you do A, if you do B, if you do C, it would minimize the risk of your particular crop or your harvest from failing. You can also use it to identify and remove weeds. There's this section of machine learning technologies called computer vision, where you can train an algorithm to differentiate between pictures, right? And so I can imagine a scenario where you can train an algorithm to differentiate between what a plant looks like, maybe like a bean plant, for example, and what a weed looks like, right? And so it helps these farmers to do this a lot quicker. And of course, you can use it to recommend effective treatment for pests and things like that. So there's absolutely no limit to what can be improved or what can be done. One of my favorite is AI for healthcare. And this one I'm particularly interested in or excited about. One, because I spent a huge chunk of my PhD in this field, but also because it's a bit real for me, right? Because we're all humans and we all need healthcare. And if there's anything that AI can improve, if it can improve healthcare, then we're all the better for it, right? And so a couple of things that it can help do One, it can help forecast health risks of various populations of people, right? So being able to study or using the data that has been gathered from people, understanding for this particular subgroup, what are some of the risks that can come out of it, or what are some of the risks that they encounter, right? And so you get more personalized treatments for people as opposed to like one size fits all treatment. It also helps to predict illnesses and treatments that you can use to cure those illnesses. Some of the work that we did back in school was, looking at electronic health records and then being able to glean that data and predict based on certain symptoms, what are some of the corresponding illnesses, right? And then also recommend treatments based on what may have been used in the past from the doctor's notes. And then it can help to assist with care records and workflow, right? Like, so how do you optimize workflow in the hospitals? How do you digest all the information that is in the healthcare records, right? So these are some of the things AI can help. It can help. This one is actually pretty matured. We've been able to differentiate between tumors and healthy anatomy. There's a lot of research and work that's been done either in the hospitals or in academic centers where people try to differentiate between like normal tissues and cancerous tissues in various organs in the body. And it also helps pathologists to make faster and more accurate diagnosis as a result, right? Because sometimes when you have like a mammogram, for example, right, it's quite a lot, right, for a human to go through that, but an algorithm or an AI is able to do that a lot more effectively and efficiently than humans can. And of course, identifying opportunities for clinical trials, and it helps to aid in drug development, and it helps to lower the cost of drug production. So like I have said, AI really does have the potential to drive considerable changes in the way that we live and in the way that we do business. And as with all great technologies that you can imagine that we've had in the past, it would also have broad impact on the society as well, right? And so AI's impact on society has started to raise a host of complex and challenging questions. And one of the biggest issues that AI is facing right now is the issues of biases in AI and biases within AI systems. And I would briefly highlight like 3 examples that have been well publicized amongst the AI community. The first was automated recruiting. This one was really, I think this case study actually went viral a couple of years back when you realized that a company was using an automated recruiting software that had AI, that was empowered by AI, and it was actually being discriminative against people. And so you can imagine it reflecting some of the biases in society. So say, for example, a particular name doesn't sound English, for example, or you can, maybe you can identify, or you could probably read through the resume and figure out, okay, maybe this person, you would want to hire this person or not, right? Reflecting some of the biases that we humans can have. And so this was a really big deal because you definitely want people to be able to get jobs, and so if the algorithm is being discriminatory, then that's a problem. And one of the other problems is oftentimes people just assume these things are perfect, and so you're like, oh hey, it's neutral, it's math, it's technology. You don't actually take the extra step to check to see what the outcome is, and you tend to take things as factual, right? And then you're not as careful as you would to check out for biases. So this was a big deal because they found out that one of the software actually had biases in the recruitment tool. This one actually was publicized, I think, back in 2015 or 2016. This particular article by ProPublica was really kick-started the field of ethics in AI, or starting to think about like biases within the algorithm. And in this particular example, it was, they found out that there was this AI tool that was being used by judges to calculate the risk of recidivism amongst people who were on trial, and then use this outcome to determine whether or not people would get bail. And then what they realized was like the tool was actually really biased against black people. And the tool itself was not perfect. It made errors, but the errors looked different for white people than it looked for black people. And by the time they started to dig into the actual algorithm, they found out that there were some issues with the way it was implemented and the way it was reading the data set. And then finally, the financial industry. This one was also publicized recently, or not recently, a couple of years back. And here, mortgage loan algorithms that were backed by AI were being discriminatory against people, right? Part of it is, for example, AI is able to, like, say, for example, you have a certain zip code, right? And AI or the tool actually realizes that, hey, this person is from this certain zip code. It's able to perpetuate some of the biases or some of the discriminatory practices that have already been festered or have already been established in that particular community. And so it was a bit problematic because certain people were denied. So you would have two people who had the exact same profile, but one person was given a loan and the other wasn't. And then when you drill down to it, it came down to the zip code the other person was from. And so this actually raised an alarm, like, hey, you have to be careful. And so and part of the reason for this is because ML is data powered, right? Like I mentioned, part of the goal is really to learn patterns in data. And so if the data, like we all believe, is reflecting, if you're gathering data from society, the data will reflect what society looks like, right? And so biases are typically encoded either within the data itself or in the pre-processing of the data. And that's what we typically call either selection bias or where some of the human biases come in. Or you would also have biases in the modeling choices as well. And that's like another field called algorithmic bias. And I would like to focus on, a specific example of selection bias or human bias that I actually find really exciting. So how does AI encode biases in the system? First, in framing the problem. Oftentimes, when you set out to solve something, right? Like I said, it starts with a business problem. And honestly, those things are typically made based on business decisions. And so sometimes biases can come in, right? Because you're trying to either optimize for something or advance something or progress something in your business, in your company, or things like that. So in framing the problem initially, like we as humans, right, we are sometimes can be narrow and have narrow vision. So sometimes in framing the problem, you actually have biases get into the system. The second way, and this is actually a big part of when biases get into the system or affects AI, is when we are collecting the data. Like I said, right, like the data tends to reflect the society that we're living in, right? And so sometimes when the data is unrepresentative, that's a huge problem, right? And also when it starts to reflect the existing prejudices in the society. And these ways, biases can also enter into the system. And the third way is in preparing the data, right? I, as a data scientist, if you give me a set of data sets and you ask me to, build a model, right? Like I mentioned, I will select certain features and attributes from that data set. And that's sort of my decisions. Those are decisions that I am making at that time, right? So oftentimes my own human biases get into the system as well. And so these are some of the ways that you can have AI encoding some of the biases that we have. And of course, the third one is algorithmic bias, which I wouldn't talk about right now, but that is really in the actual algorithm itself and how it's optimizing for gains and trying to reduce loss. And so this particular case study I actually find is really interesting to me because it sort of like highlights both human biases, algorithmic biases, as well as selection biases. And the lady you're seeing in the picture here, her name is Joy Lammy. And she was actually we're both at MIT at the time, and she was writing her master's thesis. And there was this thing she wanted to do in the lab, and she needed a facial recognition software. And so she, I don't know why she had a white mask in her office, but she put her face in front of this algorithm and it could not detect her face. And so she tried a couple, she was wondering what was going on. And then she, grabbed this white mask, put it on her face. That's exactly what that mask looked like. And it was able to detect the presence of a face. And so it sparked like this huge uproar around computer vision systems, because the technologies that she had tried were technologies that were already in production, already being used for things like policing, criminal justice, things like, biometrics, trying to access, like, hey, your bank account, for example, And so she started to look through some of these, at least at the time, 3 of these facial recognition softwares, and she realized that they were actually very biased against women and also against women of color. And the difference in the errors between men versus women and maybe white women versus black women was really big. And part of the reason was, one, the data wasn't balanced. I try to think back about some of the data sets that were collected for computer vision, right? At that time, no one is really thinking, oh, let me collect these data sets so we can build this facial recognition technology that the police can then use. No, you really just want to collect the data sets so you can get better at some algorithm, right? And then these algorithms are being used in real life scenarios and for real life issues. And so this was a really big deal back then. And as a result of her work, all of the technologies, all of the companies behind the technologies that she actually tested really went back and improved on their algorithm, and they reduced the error that was present, or the biases that was present in their system. So it can be changed, right? Like, the fact that we have biases in AI systems doesn't mean they're all bad. Things can be done about it. And so, like I said, right, the biggest issue that AI faces today has to do with like biases within the systems. And this is also why diversity is important in AI systems, because if these biases continue to go unnoticed, unchecked, they would actually harm, or it can actually harm society. We're starting to see some of it. And part of it also is really just, having people, women in the room, people of color in the room, who can, like Joy did, wonder why this particular thing wasn't working for her. And so this is really, for me, a call to action to everyone in this room to really think about how you can get involved. One, because AI careers are actually very lucrative, right? If you think software engineering is good, AI is even better. It pays really well. And really, it's really getting into society, right? Society as we know it is going to get changed the more these technologies are used. And some of the ways you can be involved is you can be a scientist, for example, which is where you're building the models. You can also be like a data scientist, where you're in charge of the entire process end to end, from actually framing the business problem all the way to an outcome. You can also be an ML researcher, where you are actually improving these algorithms and pushing the envelope on state of the art, or an ML engineer, where you're building the infrastructure for these systems, or a product manager, or an ML product manager, where you're actually defining what products need to be created. And so in closing, I would like to go back to this quote. And like I said, like, even though this is a hyperbole in terms of like what you don't see, or you cannot be what you can't see, it really underscores the importance of representation and diversity. And for me, I'm very excited that I picked up that magazine, because it has led me to where I am right now and all the opportunities I have seen. But I'm even more excited for organizations like Code Art, who really is trying to change the landscape and is really trying to change what it looks like, right? So that I no longer have to be the only in the room. And so I would like to thank you all today for listening.
All right, so I think we have time for maybe 1 or 2 questions.
Yeah.
So if anybody has a question, gentleman in the back.
Hi.
Hi.
My question is regarding the AI. Doesn't it always suggest to go on the beaten path? As you said, you were lucky to pick up the magazine, but based on AI, let's take Netflix, an easy example. Netflix would never suggest you something about that domain. Like, you would never find a magazine like the one about technology suggested to you, because based on your, like, everybody being, as you said, encouraged to go into being a doctor, So if you watch the same things on Netflix, you will never see suggestions about something else outside of your comfort area. It doesn't really promote an open mind. Thank you.
Yeah. Yeah, that's a very good question. So he's talking about how AI, how can, or if I can rephrase, sort of like how can AI promote an open mind, right? Because oftentimes it repeats what it has seen. That's very fair, and I think that's part of the problems, right? One of the issues that we're seeing with AI, right? Since it's really powered by data, it really sort of like regurgitates what it has seen. And so yes, that is a problem. But there are some fields in AI right now, and I didn't talk about this. This is reinforcement learning, which is actually more of an active learning that is going on. So not just like history, past, and then learn from that, but how can you train an agent to make more active discussions? How can you train an agent to discover new things? And so that is coming. You primarily see that in games right now, but that's a field that is very fast growing and it probably has the potential to be more of a discovery as opposed to in history. But that's a very good question and one of the big issues that we have with AI today. One more question. Oh, we have,
Sorry.
can we? Okay, we'll take one more. No worries.
Hello, how are you?
Hi.
I enjoyed everything you have just said. My question is about, you said sometimes you're the only one in the room. How, being a minority, I too am into computer science and things like that. And I know that I've had a really, really hard time. I'm an educator. So when I started off, it was kind of like not what I expected. What helps you, what makes you continue to at least go on, even though, those of us that look like you and me, we're really given a hard time in this field as computers. I was told that we're not smart enough and things like that. So I just want to know what you did today was phenomenal.
Thank you.
And I would like for my students, I'm teaching computer science education right now. I am also a former adjunct professor from Florida Memorial University. But I want to know, what keeps you going, and I want to see more like you and what you're doing. Okay.
Thank you. Thank you so much. We'll definitely talk a lot more about this at the panel that is coming right after this, I think. But I think part of it for me is my firm belief that representation matters. I really believe that. And so in those days where I'm like, oh no, I remind myself, right, that there's someone out there who needs to be inspired, just like I was when I saw that magazine. But I'll definitely talk more about some of the other strategies I use at the panel. Can we take one question from one of the girls?
Absolutely.
Yes.
Yeah. So one of you guys had your hands up. So.
Yeah, well, it's my daughter's question, but she's shy, so I'm going to ask it for her.
Okay.
She's thinking about a career in data science, and we wanted to ask, what does your actual 9 to 5 look like? It's not like a very exciting question, but a practical question. What do you do all day?
Interesting. I'll try to answer this as quickly as possible. So now I'm a manager. So my actual day is probably in meetings, talking to people, making sure my team has all that they need. But before I was a manager, what my actual day looked like was one, I would have a particular problem. Say my project had to do with improving productivity in office, for example. And I would have data sets that have already been collected. And so what I would do then on that day is, one, I have the data, I pull it into my computer, and then I try to explore. That's what we call like the exploratory data analysis. What are some of the interesting patterns that I can already see in it? Because then that would form how I would go ahead to model, right? I would probably have some graphs or some visualizations that I would run by my manager to get some of his insights. And so once I have formed some hypothesis about what I am trying to do, and then I start to run some of these ML algorithms that I talked on this data, either trying to, predict something better, or how do we surface a better command to a user. So the actual running those algorithms. And then once I train those algorithms, then I'm able to then use it, pass it on to my engineer colleagues who can then upload it into PowerPoint, for example, and then an end user would be able to interact it as they use PowerPoint. So that's in a nutshell what my day-to-day looks like, but it's very much staring at a computer screen, looking at data that's typically either numbers or letters, and then getting outcomes, getting outputs, getting graphs, and making decisions. But yeah, thank you.